Here's guidance for exercises 1 and 2 on page 245. I'm not going to take you through all of them, just some of it, and you can try the other one on your own. Once you get one, the other one should be pretty straightforward. So for the first one, you're given a sample size of 625 people, and 125 reported that they missed at least one class or class quiz or midterm because of illness, right? That is 125 out of 625 is 125 divided by 625. You can do it with a calculator. That's basically 0.2 or 20%. So 20% respond accordingly, right? Now the A is asking for the 95% confidence interval. That's given by 1 square root of n. So in this case, it's 1 divided by square root, 1 divided by square root of n. That's 1 divided by square root of 625, which is 1 plus or minus 1 divided by 25, which is, when you do the math, it's 1 out of 25, divide 25 into 100, it's 4 quarters, so 0.04 or 4%. That should be not and, but 4%, okay? So your interval is then 20% plus or minus the 4%. Again, your not mean, mu, but the thing you're asked about, the proportion, is 20%. The 95% confidence interval gives you the margins of error, plus or minus this, which you calculate from the formula. So you have to memorize those three formulas, right? One, basically, of course, it's roughly 1 sigma, 2 sigma, 3 sigma, but it's different. Remember, for confidence, you have 3 differing formulas, but you still have the same 68%, 95%, 99%, but the formulas are different, okay? So this one is 1 divided by square root of n gives you the plus or minus 4%. You then couple that with the 20% to give you the actual interval. 16%, which is 20 minus 4%, and 24%, which is 20 plus 4%. You're saying that 95% of the time, you are confident that your results fall within that margin of error. Yeah? Okay. The method is what gives you that confidence. So the accuracy of the 20% having reported this as reflective of the real population, do 20% of the students actually, is this actually true? Well, according to this method, since you didn't ask all the students, you just asked 125 out of the 625, and maybe your total student population on campus is like 10,000, right? You only did 625 sampled out of them. Your estimate of 20% meeting the actual reality is within the margin of error 16% to 24%, okay? You try on your own the 99% confidence interval. The second one is the same type of exercise as the first. You have to just do the calculation. So they ask again for the 95% confidence interval. That formula you have to memorize is 1 divided by square root of n. In this case, they do a smaller sample size. So they don't ask 625 students, they ask 81 students. Think about it intuitively. If they ask less students, do you think the accuracy of your poll will be greater? No. The more students you ask, the better your estimate will be, but it's more labor. The less students you ask, the less accurate your survey will be, but it's easier. So when you calculate this, 1 divided by square root of n, 1 divided by square root of, in this case, 81, that'll be plus or minus 1 over 9. 9 times 9 is 81, which is roughly 11%. So in this case, the confidence interval is 20% minus 11, 9%, and 20% plus 11, 31. So in this case, the confidence interval is much worse than the above, which is 16 to 24. All right, you guys can do likewise here, the 99% confidence interval, just for practice to get this down. Remember that confidence is one of the questions that you're going to be getting on the final. You have to do this type of calculation. Unlike with significance, where you do mu and sigma and then the 3 facts, for confidence it's different. You have to memorize the 3 confidence facts, which are different. Use the formula, figure out the proportion, and then do plus or minus from that proportion after you figure out the interval. That is to say, in this case, the proportion is 20%, and then plus or minus whatever you asked to do. In this case, it ends up being 4% to get the interval. Okay, that's it.